Right, the point of this video is to help people use their calculators to incorporate the frequencies into their calculations, because I noticed on the homework that was not always done correctly. So I've got two examples here, two different sorts of frequency distributions. And the first one just gives you some ages, like you ask some people what their age is, and you got this number of 11-year-olds and 12-year-olds and so on. So how do we find the mean, the median, all those things? On the calculator, of course, you start with list and spreadsheet page. And it's a good idea to label the names of the columns with what it is you want to talk about here. It's hard, apparently. Oh, okay, so watch what happened there. When I got to the Y, the letters stood up. That means I can't use that name because it's a command on the calculator. So I'll just call it freak. And I'll enter the ages in like that. And then the frequencies. Making sure that I have the right frequencies there. Okay. So once they're in, you know how to use one variable statistics at this point. So stat calculations, one variable statistics. It is one variable, not two variable. For two variable statistics, that would require that you have an ordered pair where an X and a Y value go together. For instance, if you asked each person's age and their grade in school, then you could have an age, comma, grade in school for each kid. But that's not what you've got. You've got, there are two 11-year-olds. So the one variable is how old are you? And that's one list of how old you are. For the X1 list, if you arrow to the right here, you can choose that age is your list, enter, and then tab to the next one and arrow out and choose frequencies here. That's the essential thing. If you leave that off, you'll get an answer that seems plausible, but is nevertheless incorrect. I'll show you what that looks like in a minute. So choose the frequencies, and then if your cursor is in the last column that has data in it, the first result column will be on the side, which is good. There you go. So this is what we needed. There's the mean. And median is a little further down. There's the median. I didn't put in this question that one should find the mode because, of course, the mode is easy to see. The mode is the thing that's most frequent, which is clearly 15 because there's 6 of those. And also because the calculator doesn't have a command for that. I'm trying to get some room where I can make these smaller. Next is interquartile range. To get the interquartile range, you'll need the two quartiles, the third and the first quartile. And those are things that you can see on the screen as well. So quartile 1 and quartile 3 are right here for us. In fact, you can see the entire 5-number summary, the minimum, maximum, quartiles, and median, all at once. So to get the interquartile range, we would do Q3 minus Q1. So Q3 minus Q1 is 16 minus 13 is 3. The standard deviation, for this course, we assume that everything's a population. In real life, everything's not a population. In fact, most things aren't populations. But for the purposes of this, we'll assume that these are all the ages we're interested in, is everybody we care about, and so it could be a population. The standard deviation you want is this population standard deviation, which is the one with the sigma in it. The other one, the one with the S, is the sample standard deviation, and that's very useful as well, but just not what we're asked for here. Okay, so here's the thing about this software. It wants to distort. Here we go. So the standard deviation is about 1.75. And then the variance is the square of that standard deviation. There's a couple different ways to do that. One of them is to just go sort of on the side here next to standard deviation and tell the spreadsheet to square that. And because this is a spreadsheet, just like an Excel or something, you type equals, and you click on the cell you want. And what's a little bit different from Excel is you have to enter here to tell it to take that, and then squared, and that's the variance. Another good way to get the variance is to, on a calculator page, go to the variables menu, and all these stat dot things, every time you do a statistical calculation, like one variable statistics, all these variables populate with things. And if you scroll down, you will find that one of them is the standard deviation. There you go. And then you can square it. You could also, in that same variables menu, look a little further, stat 6, because apparently since I first opened a document, I've done this 5 previous times. Stat 6, and yeah, it's the last one. It will stay there. So every time you do a new calculation, all the stat dot without a number, those will rewrite. But stat 6, if you know which one it is, those will be there for the long term. Another thing that's possible to do is if you go to the catalog, the book icon here, variance starts with V. So I shall type a V, and notice there is a command for the population variance. It asks for the list, comma, the frequency list. So if I choose that, then the list was ages, comma, and the frequency list was freak. And ooh, pretty. That's the same answer. So there's lots of ways to get this answer. Any one of them would do just fine. I'm going to copy this one. To make a histogram on the calculator, not that that's always required, but it can be pretty handy to see a picture of sort of, is there a skew or whatever, without having to do a lot of calculations. If I go back to the calculator and put the kind of page on which one gets graphs in data and statistics, it's this one. You can see the little picture of a bar graph there. If I choose that, I get this nonsensical thing. It means nothing. On the horizontal axis, I'm going to choose age. So click here, pick age, and you get what's called a dot plot, which is also kind of meaningless. I mean, there's not just one of everything, because the calculator doesn't know about the frequencies. All I told it was the age. So if I go to menu and plot properties, you can see that there's an add Y summary list. I would like to summarize the number of each of these values on the vertical axis. So if you choose that and tell it the frequency is there, oh, bam, there it is. It's pretty nice. You can see right away what's going on with the data. One wonders about whether the scale is what we want. Like, does it make sense that the bar goes from 11 to 12 instead of being centered around 11? I think it's entirely possible to argue that that's exactly how it should look. When someone's 11 years old, it's from the day they turn 11 until the day they turn 12. So if you're 11, then you're somewhere between 11 and 12 years old. I think that's probably exactly what we want. And so that's really quick to see what shape the data might have. Is this symmetric or skewed or that sort of thing? Are there lots of people very old or mostly very young without having to do any, especially if there's lots of numbers, any hard thinking about it? It's also possible, if we go back to that, if you click on one of the bars or even just hover over it, you can see those things. There's one. It says in the interval from 15 to 16, so 15 is less than or equal to age is less than 16, because the square and round brackets, there are 6 values. So it will tell you the 6 values. If I click on it, I can highlight, and I thought they stated it doesn't. So very nice. You can deal with those things. Why do I have a second page? Why did I say I would do 2 examples? Because here is a different type of information. In the first one, we knew 2 kids were 11, 1 kid was 12. Here what we have is the wages are on an interval. It's good notation. The wages between 720 and 740, but including the 720 and not the 740. The difference in entering this is that we don't just have how many people are 11 and how many people are 12. We have something a little bit more interesting. So I'll start the same way, and I'll call this wage, and I guess number of, okay. If I do control space, I can put an underscore there, workers. What numbers you should put in here are the mid-interval values. Halfway between 720 and 740 is 730. That's what you want. The next one would be 750, and so on. It's possible to do the thing where you drag down like in a regular spreadsheet, but that's difficult to do with a trackpad. So since I have the advantage of a mouse, it would look not as difficult for me as you would experience it to be. So I'm just going to do it this way. Last one is 870. And then I'll once again put my counts in here. This is still one variable data because the only variable we have is how much does that worker get paid. The right-hand column is just a bunch of how many people earn that much. And the book that I got this from is actually from Australia, so those are probably Australian dollars. So got the numbers in. Ask the calculator for the statistics, calculations, one variable, statistics again. Still one list with the arrow. This time the X list is the wage, tab down, and the Y list is the number of workers. Notice there's a whole bunch of extra stuff here because the previous calculations things are available, and that means it's sometimes harder to find things in the list. When you name variables, sometimes it's handy to name them with letters that come before STAT, like start with SI or start with B, rather than things that start after that. So you're going to scroll so far. And this will give me what I'm looking for. So a mean of $780 and looks like 60 cents. I'll put these in, and then I want to show you what happens if you don't use the frequencies, because you'll get answers that seem like they'll be okay, and they will absolutely be completely incorrect. That's all the ones I needed to copy. So I guess for completeness I'm doing this. Units on these make sense. So the age, these are all actually years. So 14.48 years exactly. Okay. Assuming everybody's just a single year. 15 years old, that sort of thing. The standard deviation is also measured in years, as is the interquartile range. The variance is actually measured in square years, which is strange but true. Over here, the numbers that we're looking at are wages. So this is $780.60 to make it look like money. The standard deviation is $31.74 per, presumably this is per week. I don't know what that's, I don't know what else that would be. The median is $770. It's got to be per week. The quartiles would subtract, that would be 790 minus 750 is $40 for the interquartile range. And the variance is going to be sigma squared, which is 31.74 squared. Which I'll just do here. Equals, click on that, and then hit enter. So it takes that dotted line away, and then squared, about 1,764. That's not 3 sig figs. In fact, neither is the standard deviation. I didn't rewrite it. If this were an exam, you might be told with money things to give them to do decimal places. You might be told to give them to a whole dollar. You might be told nothing at all, which means 3 sig figs. Just make sure you read what it is it says. So the units on this last one, if the standard deviation is in dollars, then the variance is in square dollars, which is, how do you even write that? I've never seen this, so I don't think that's right. I'd probably just leave that nonsense off. And the histogram works the same way. Nothing very interesting there, I think. Let's see, haven't actually tried it. So it will be the wage on the horizontal. And then remember, you don't just click out a variable. That won't work. It's menu, plot properties, Y summary list. On the Y-axis, we want to summarize the number of values. And that was called number. How long did it take? There we go, number of workers. Now, this one, the bars don't touch. The last one they did. I mean, that's what a histogram looks like, right? This one, even more so than the last one, should have bars that touch. Because there definitely is no space between these things. So, plot properties, histogram properties, bin settings. I want the bins, which are the intervals, to be wider. Equal bin width is good. And then, what's the width? Well, I can see here the width should be 20, so I'll change that to 20. The alignment is a bad name for that. It means where should I start the first interval? And starting the first interval at 720 is exactly what I do want. So there we go. Now you can't really see the 720. So I can slide this over a little bit, she says, hoping it's true. There, like that. I think, let me go back. Yeah, window, I can also do that with the window and tell it to start at maybe 710. There we go. Let's see that a little bit better. Now, the one thing I said I was going to do that I have not done yet is show you what happens if you leave the frequencies off, because it's a real problem. It's, in many cases, when you make a mistake in math, you get an answer that's that points out to you that you're wrong. Like you get a negative, it was supposed to be positive. You get a decimal, it was supposed to be an integer. You get an answer in the thousands, and it was supposed to be more like 15. That doesn't happen if you leave off the frequencies, because it's going to use the right numbers here, just the wrong counts. So on this list and spreadsheet page, I'm going to add a new one variable statistics calculation. And this time I'm going to tell it to use the wages, but not to use the frequencies. I'll leave that off. Here's what I get. I get a mean of 800 instead of 780. That's ballpark. It's just not right. I get a median of 800 instead of 770. Again, that's about the right size, but it's the wrong number. For the interquartile range, I would get 840 minus 760, which is 80, not 40. For the standard deviation, I would get 4582, 4583 instead of 31. These are all things that are plausible, but they're wrong. And that's because it's using the right size values here, but not the right proportions of them. So it really does matter that you incorporate the frequencies into the commands. And I hope this is useful because I've talked longer than I intended to.